Hello everyone, welcome back to our channel gsipucmysuru. This is the session 2 of the 8th chapter, that is modulation and demodulation. In the first session we discussed about what is the meaning of modulation and the different types of modulations like amplitude modulation, frequency modulation and phase modulation. Apart from that, we also saw what is the need for modulations. There are different reasons why we are going to modulate the signals, the actual signals. Some of the reasons can be the length of antenna, the wireless communication, mixing of signals, multiplexing, reduction of noise and interference. So these are some of the reasons why we are going to modulate the signals. In today's sessions, we will be starting with the amplitude modulation. In the last session itself, we discussed about the definition of this amplitude modulation. For a modulation, we need two separate signals. One is called as the modulating signal, which is nothing but the actual signal which has to be transferred from one place to another place. And that modulating signal can also be called as the baseband signal or the intelligent signal. And the other signal which is used as the carrier is called as the carrier signal. So these two signals, that is the modulating signal and the carrier signal, will be given as input for one single circuit, what is called as a modulator. From there, we are going to get the output, what is called as a modulated signal. Definition anta bandaga, the process in which the amplitude of a carrier signal varies in accordance with the instantaneous value of the modulating signal or varies in accordance with the amplitude of a modulating signal, keeping frequency and phase constant, is called as amplitude modulation. We are having a modulating signal like this, whose frequency is very much less, whereas the carrier signal like this, whose frequency is very high. So in the amplitude modulation, we are going to vary the amplitude of this carrier signal in accordance with the amplitude of this modulating signal, keeping the frequency and phase constant. That is what is the meaning of this amplitude modulation. Now let us try to derive an expression for the instantaneous value of a modulated signal, that is amplitude modulated signal. Instantaneous equation of an AM wave. So what is this instantaneous equation of an AM wave anta helidre? What will be the amplitude of the newly modulated signal, that is the output of the modulated circuit, adar the amplitude ಏನು ಆಗಿರಕ್ಕೆ ಸಾಧ್ಯ ಅನ್ನೋದನ್ನ ನಾವು ಈ equation ಮೇಲೆ ಡಿಸೈಡ್ ಮಾಡಬಹುದು. So that is the most frequently asked question in the exam. Derive an expression for the instantaneous equation of an amplitude modulated wave. So let us draw a clean diagram. Let us consider that I am having a modulating signal whose amplitude is Vm. Let us denote the amplitude of that modulating signal with Vm. And I am having a carrier signal whose amplitude is Vc and frequency is very large. Amplitude, let me denote this amplitude by Vc. So this is a modulating signal, that is the actual signal which is to be transferred from one place to another place, and this is a carrier signal whose frequency is very large and its amplitude is denoted by Vc. Now have to come up with a new waveform which is called as the amplitude modulated wave, and that amplitude modulated wave will be like this. The positive half cycles, negative half cycles must be plotted. This Vc, this line, let me consider that as Vc, and for the positive half cycle of the modulating signal, the amplitude of this carrier signal will increase ಅಂತ ಹೇಳಿದಾಗ initially its amplitude is equal to Vc. Now it's going to increase ಅಂತ ಹೇಳಿದ್ರೆ the amplitude will go beyond Vc. So the amplitude for the positive half cycle of a modulating signal will be above Vc. For the negative half cycle of the modulating signal, the amplitude of this carrier signal decreases. That is, it goes below that VC line. So, goes below that VC line anta helidre ee tara baribeku. For again the positive half cycle, it will be like this. But this modulated signal contains the waveforms in both positive as well as negative cycles. Ee tara waveform barutte, and the frequency of this particular signal is same as that of frequency of a carrier signal. Carrier signal the frequency ಏನು ಇರುತ್ತೋ ಅದೇ frequency ಇರುತ್ತೆ, but amplitude ಮಾತ್ರ will entirely depend upon the amplitude of a modulating signal. So this can be called as an envelope which contains the actual modulating signal. So what is this amplitude modulation? The amplitude modulation is nothing but the process of varying the amplitude of the carrier signal with respect to or in accordance with the amplitude of a modulating signal, keeping frequency and phase constant. We are maintaining the same frequency. The frequency of this carrier signal as well as the frequency of this modulated signal, both are same. But this modulated signal amplitude is different from the amplitude of the carrier signal. But the amplitude of this modulated signal is entirely depending upon the amplitude of this modulating signal. Clear? Now let us try to derive an expression for this, that is instantaneous equation of an AM wave. This itself is an AM wave. This is VC, that is the amplitude of a carrier signal. Sometimes the amplitude of this particular signal will go above VC and sometimes it falls below VC. Let us write an expression for this modulating signal. The equation of a modulating signal, instantaneous equation of a modulating signal is given by Vm equals Vm sin omega mt. Vm, small letter Vm equals capital letter Vm sin omega mt. This small letter Vm is nothing but instantaneous equation of a modulating signal. Whereas capital letter Vm is the amplitude of a modulating signal. Amplitude of a modulating signal. Omega m is nothing but the angular frequency which will be given by 2 pi fm, where fm is nothing but the frequency of modulating signal. So Vm equals Vm sin omega mt is the instantaneous equation of a modulating signal. What is the meaning of this instantaneous equation anta helidre? This waveform we are plotting across the time period. Instantaneous equation anta helidre yaude time period nallu kuda nanu ee equation na baribodu. I can easily find out the voltage, or here I am considering the amplitude. The amplitude of this particular waveform at any instant of time. At any instant of time ಅಂತ ಹೇಳಿದಾಗ instantaneous equation. By substituting the t value ನಾನು substitute ಮಾಡಿದ್ರೆ ನಮಗೆ ಇಲ್ಲಿ instantaneous equation value ಗೊತ್ತಾಗುತ್ತೆ. At that particular time period, what will be the amplitude of that particular signal? See, for example, ಈ time period ನಲ್ಲಿ the amplitude is equal to 0. At this particular time, the amplitude is maximum. So at that time period, we are going to measure the amplitude of that signal. Then we are going to get the instantaneous equation of a modulating signal. Similarly, the instantaneous equation of a carrier signal. The instantaneous equation of a carrier signal will be given by small letter Vc equals capital letter Vc sin omega ct, where Vc is nothing but the amplitude of a carrier signal which is constant before the process of modulation. The Vc is nothing but the amplitude of a modulating signal. Omega c is the angular frequency of a carrier signal, which will be given by 2 pi fc, where fc is nothing but the frequency of carrier signal. We have to note that the frequency of the carrier signal is very much high compared to the frequency of this modulating signal. That is, Fc is very large compared to Fm. In these two equations, that is instantaneous equation of a carrier wave and the instantaneous equation of modulating wave, ಎರಡರಲ್ಲೂ ಕೂಡ we have ignored what is called as the phase. Phase na ನಾವು ignore ಮಾಡಿದ್ದೀವಿ. But the amplitude of this carrier signal is constant, whereas the amplitude of this modulating signal is not constant. But after the process of modulation, the amplitude of this carrier signal will vary in accordance with the amplitude of this modulating signal, and that is why it is named as amplitude modulation. Initially it is Vc, but after the modulation process, the amplitude of the carrier signal vary ಆಗ್ತಾ ಇದೆ depending upon the amplitude of this modulating signal, but the frequency of these two signals are same. The frequency of a modulated signal is same as that of the frequency of a carrier signal. Clear? I am more concentrated with these two equations, that is Vm equals Vm sin omega mt, Vc equals Vc sin omega mt. So let me write only those two expressions separately. Let me call this particular equation as 1 and this as equation number 2. This is the instantaneous equation of a modulating signal and this is the instantaneous equation of a carrier signal. Now we have to find the equation for this particular signal, that is a modulated signal. Here if you look at this particular equation, the term which comes before this trigonometric function is nothing but the amplitude part, and which comes after this trigonometric function is called as the frequency part. So if I am going to consider A as the amplitude of the new signal, I don't know what exactly is the amplitude of this new signal. So let me denote that amplitude of a new signal with A, and that A will be equal to the amplitude of this carrier signal. This starting initially Vc ಇದೆ, Vc ಗಿಂತ ಕೆಲವು ಸರಿ ಜಾಸ್ತಿ ಆಗುತ್ತೆ and Vc ಗಿಂತ ಕೆಲವು time it keeps on reducing. So Vc plus Vm. I have written capital letter Vc, that is the amplitude of a carrier signal, plus the instantaneous value of this modulating signal, that is small letter Vm. Because the definition of amplitude modulation tells me that itself. That is, the amplitude of a carrier signal varies in accordance with the amplitude of a modulating signal. So, Vc ಏನಿದೆಯೋ ಅದಕ್ಕಿಂತ ಕೆಲವು ಸರಿ ಆ್ಯಡ್ ಆಗುತ್ತೆ ಅಥವಾ ಕೆಲವು ಸರಿ ಸಬ್ಟ್ರಾಕ್ಟ್ ಆಗುತ್ತೆ. So, the new amplitude will entirely depend upon Vc, that is the amplitude of a carrier signal, plus instantaneous equation of a modulating signal. But Vm is equal to this much, Vc plus, let us substitute that, Vm sin omega mt. If I am going to take Vc as the common factor from this particular expression, I am going to get 1 plus Vm by Vc sin omega mt. A is equal to Vc into 1 plus Vm by Vc sin omega mt. But this Vm by Vc can be considered as Ma, 1 plus small letter Ma sin omega mt, where Ma is equal to Vm divided by Vc. Vm is the amplitude of a modulating signal, Vc is the amplitude of a carrier signal, and this Ma is called as the modulation index. We are going to see what exactly is the meaning of this modulation index. So, Ma is nothing but the modulation index, which is given by the ratio of modulating signal, modulating amplitude to the carrier amplitude. So, the expression for the amplitude of the new signal is equal to Vc of 1 plus Ma sin omega mt. But the instantaneous equation of an AM wave can be written as, let me denote that by a small letter VAM. Small letter VM stands for the instantaneous equation of modulating signal, and this instantaneous equation of a carrier signal, whereas this instantaneous equation of a new signal, that is the amplitude modulated signal. So this will be given as the new amplitude that is taken as A and into sine omega ct. Why I have written this sine omega ct? Because the frequency of this new signal is same as the frequency of a carrier signal. I am changing the amplitude of this carrier signal only in order to get the new modulated signal, keeping the frequency constant. So the new ಸಿಗ್ನಲ್ನ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಏನು ಬರುತ್ತೆ ಅಂತಂದರೆ ಆಂಪ್ಲಿಟ್ಯೂಡ್ ಪಾರ್ಟಲ್ಲಿ ಮಾತ್ರ ನನಗೆ ಬೇರೆ ಇರುತ್ತೆ, ಆ ಫ್ರೀಕ್ವೆನ್ಸಿ ಪಾರ್ಟಲ್ಲಿ ಹಾಗೆ ಉಳ್ಕೊಳ್ಳುತ್ತೆ. ಸೊ ಎ ಸೈನ್ ಒಮೆಗಾ ಸಿ ಟಿ. ಸೊ ವಿ ಎ ಎಮ್ ಈಕ್ವಲ್ಸ್, ಬಟ್ ಎ ಜಾಗನಲ್ಲಿ ಏನಿದೆ, ವಿ ಸಿ ಆಫ್ 1 ಪ್ಲಸ್ ವಿ ಸಿ ಆಫ್ 1 ಪ್ಲಸ್ ಎಮ್ ಎ ಸೈನ್ ಒಮೆಗಾ ಎಮ್ ಟಿ. ಎ ಜಾಗನಲ್ಲಿ ಐ ಆಮ್ ಹ್ಯಾವಿಂಗ್ ದಿಸ್ ಎಂಟೈರ್ ಥಿಂಗ್ ಆ್ಯಂಡ್ ಔಟ್ಸೈಡ್ ದ ಬ್ರ್ಯಾಕೆಟ್ I am having sine omega ct. Hodalva? If I am going to split this expression, Vc of sine omega ct plus ma Vc of sine omega mt into sine omega ct. But this is of the kind sine A into sine B, which will be given by the relation 1/2 of cos A minus B minus 1/2 of cos A plus B. This is the expression. So, in place of A and in place of B, we are having omega m and omega c. But out of omega m and omega c value is very, very large, because omega c is nothing but the angular frequency of a carrier signal, which is very, very large. So this expression can be written as, this will be retained as it is, Vc sin omega ct plus ma Vc by 2 is constant, so that will be written separately, ma Vc by 2, sorry, ma Vc is constant, so hagagi ma Vc divided by 2 cos of A jaganali, let me consider as omega c, and B jaganali omega m t minus ma Vc by 2 of cos omega c plus omega m. So this is the final expression for the instantaneous equation of a amplitude modulated wave, that is Vc sin omega ct plus ma Vc by 2 cos omega c minus omega m of t minus ma Vc by 2 cos omega c plus omega m of t. So this is the final instantaneous equation of an amplitude modulated wave. So this question will be most frequently asked in part E of the question paper for 5 marks. If you look at this particular equation, I am having 3 different components. This is one component, this entire thing is another component, and this is one more component. So this contains 3 different components, in which the first component is same as that of this Vc sin omega ct. That is, the final signal, that is the modulating signal, contains the carrier signal component also, plus the other 2 components will be called as the lower sideband component, and this will be named as the upper sideband component. Let us try to draw the frequency response of this particular equation. Frequency response of AM wave. Frequency response antandre bere enu alla, it is nothing but a graph of frequency versus amplitude. Here we are having 3 different components. One is called as the carrier component, and this is called as the lower sideband component, and this is called as the upper sideband component. Here omega c minus omega m anta ide, omega c minus omega m. So omega c can be written as 2 pi fc minus 2 pi fm, because omega c is 2 pi fc, omega m is 2 pi fm. So 2 pi na common tegidre I will be left with fc minus fm, whereas the frequency of this carrier component is just fc, whereas the frequency component of this particular expression is fc minus fm, whereas this is fc plus fm. So fc centrally barkondo, fc minus fm, obviously it will be below fc, fc plus fm it will be above fc. So if I am going to draw the graph of frequency versus amplitude, we will be having the center frequency which will be called as, which will be marked as fc, whose amplitude is the carrier component idu, other the frequency is fc, amplitude is vc. So amplitude is vc, whereas frequency is fc. The next component, that is ma vc by 2 cos, ma vc by 2 is nothing but the amplitude. So that will be plotted as the frequency fc minus fm. So that comes to the left side, whose frequency is fc minus fm, amplitude is ma into vc by 2. Adhe thara last component frequency is fc plus fm, which comes to the right of this. So it is fc plus fm, that is the frequency is fc plus fm, and amplitude is ma into vc by 2. So I am having three different components. The central component is the carrier signal component, and these two are called as the sideband component, whereas this is called as the lower sideband, which is denoted by LSB, and this is called as the upper sideband, which is denoted by USB. The lower sideband frequency is fc minus fm with an amplitude of ma into vc by 2. Upper sideband is having a frequency of fc plus fm, and amplitude is ma into vc by 2. Here the carrier signal frequency is fc with an amplitude of vc, but the frequency range which lies within this upper sideband and the lower sideband is called as the bandwidth of that particular signal. fc plus fm is nothing but the frequency of this upper sideband, fc minus fm is nothing but the frequency of the lower sideband. If I want to calculate the range between these two, that is bandwidth anta bandaga, FUSB minus FLSB, which is equal to fc plus fm minus of fc minus fm. So which can be written as fc plus fm minus fc, minus into minus plus fm, fc cancel ಆಗ್ತದೆ, ಉಳಿಯೋದೇನು 2fm. So the bandwidth is 2fm in case of this amplitude modulated signal. So what is this bandwidth? Bandwidth is nothing but the range of frequencies which can be handled in a particular device. ಈಗ see for example, ನಮ್ಮ ಮೊಬೈಲ್ ಫೋನನ್ನು ಕನ್ಸಿಡರ್ ಮಾಡಿಕೊಂಡ್ರೆ, our mobile phone is having a capability to capture the radio signals. That too, the radio signals ಅಂತ ಹೇಳಿದ ತಕ್ಷಣ ಅದರದ್ದು range will be fixed. Our mobile phone will be designed only to capture the frequencies of some particular range. ಆ ರೇಂಜ್ಗಿಂತ ಜಾಸ್ತಿ ಅಥವಾ ಆ ರೇಂಜ್ಗಿಂತ ಕಡಿಮೆ ಅಂತ ಬಂದಾಗ our mobile phone will not be able to capture those frequency signals. So bandwidth, the maximum and the minimum frequency ranges which can be captured using a single device is called as the bandwidth. So bandwidth in an amplitude modulated wave is equal to 2 times of fm, where fm is nothing but the frequency of a modulated signal. So this is the derivation for the instantaneous equation of a modulated signal, that too amplitude modulation signal. So how we are going to derive that? We are going to take two separate equations. One equation will be considered as the instantaneous equation of a modulating signal, which will be given with this And this is the instantaneous equation of a carrier signal which is given by Vc sin omega Ct. But in the modulation process, the amplitude of a carrier signal will vary in accordance with the amplitude of a modulating signal. So let us denote that new amplitude with A, and that A will be equal to Vc plus instantaneous equation of a modulating signal, where Vc is the amplitude of a carrier signal. If I am going to substitute for this Vm over here and take Vc as the common factor, I will be left with this Vc of 1 plus Vm by Vc sin omega mt. Vm by Vc can be termed as Ma, which is called as the modulation index. A stands for amplitude modulation. ಇಲ್ಲಿ MF next frequency modulation ಅಲ್ಲೂ ಕೂಡ ನಮಗೆ modulation index ಅಂತ ಬರುತ್ತೆ, which will be denoted by MF. So F stands for frequency modulation over there. Here A stands for amplitude modulation. So MA is nothing but Vm divided by Vc, which is the ratio of the amplitude of a modulating signal to the amplitude of a carrier signal. Now the new equation of a modulated signal will be written as A into sin omega Ct. A is nothing but ಎಲ್ಲ equation ಅಲ್ಲೂ sin term ಅಥವಾ cos term ಗಿಂತ ಮುಂಚೆ ಬರುವಂಥದ್ದು amplitude part, sin term ಅಥವಾ cos term ಆದಮೇಲೆ ಬರುವಂಥದ್ದು frequency part. So the new equation ಏನಿದೆ ಅಥವಾ new modulated signal ಏನಿದೆ ಅದರ amplitude ನಂಗೆ ಇನ್ನೂ ಗೊತ್ತಿಲ್ಲ. I have taken that as A in this particular expression. So A sin omega Ct. Why I have written sin omega Ct? Because the frequency of the modulated signal is same as that of the frequency of a carrier signal. ಹಾಗಾಗಿ sin omega Ct na retain ಮಾಡ್ಕೊಂಡಿದೆ. If I am going to substitute for A in this particular expression from this term, we are going to left with Vc sin omega Ct plus MAVC sin omega mt into sin omega Ct. But in the trigonometry, we are having the expression for sin A into sin B as this. If I am going to substitute that particular expression in this equation, we will be left with Vc sin omega Ct plus MAVC by 2 cos omega C minus omega m of t minus MAVC by 2 cos omega C plus omega m of t, which is the final expression for the instantaneous equation of a amplitude modulated wave, which contains 3 different components, which is termed as the unmodulated carrier signal component, the lower sideband component. Lower sideband anta yake helteve because omega C minus omega m ide. Lower sideband component and the upper sideband component. Then we will be drawing the frequency response of a AM wave. Frequency response of an AM wave is nothing but it is a graph which is plotted between the frequency and the amplitude of an AM wave. So we will be getting 3 different components. The middle component is the unmodulated carrier component, and these two are called as the sideband components. To the left we will be having the lower sideband component, which is having a frequency of Fc minus Fm, amplitude MAVC by 2. To the right of this carrier component we will be having the upper sideband component, which is having a frequency of Fc plus Fm and amplitude of MAVC by 2. One thing what you have to observe here is the amplitude of both the sidebands are same. MAVC by 2 itself is the amplitude of both lower sideband as well as the upper sideband. Bandwidth anta bandaga it is the difference between the upper sideband frequency and the lower sideband frequency, which will be given by 2 times of Fm. I hope you are very much clear with this expression. This is the most frequently asked question in your exams. So let me conclude this session at this point. I will be coming soon with the new session. Until then, take care. Bye-bye.